Hi, my name is Ken, and this is Let's Code a Mud in C++11, Part 12. In the last part, we started putting an interface together. We took our interface code and separated it out from all the networking code. And we wrote just a really stupid dummy interface that takes a username and a password, any username and a password, and then gives the user a command prompt and just repeats their commands back at them and doesn't actually do anything. So what I want to do over the course of the next couple episodes is build up a command system, but to make our lives easier doing that, what I actually want to do in this part is I want to write what's called a tokenizer. So what I want to do is I want to take our line of text and I want to break it up into individual words and strip out all the white space and any non-printable characters in there and just write a utility class that does that for us. So I'm going to write that and I'm going to add that into a new component because it's not really application logic. This is a utility. This is infrastructure, but it's also definitely not networking code. So I'm going to go to here and I'm going to add a component called dictionary. And the reason I'm calling it dictionary is because this is going to be the first of a couple classes that deal with how we recognize words and how we look them up and parse them and that kind of thing. So there will be a dictionary. But for now, we're just tokenizing. Okay, so dictionary tokenizer.hpp. Let's write our include guard. And if do our namespace here, namespace mud, and namespace spell correctly, namespace dictionary. Okay. And then class tokenizer. All right. So, what do I want this to look like? So, I said I want our tokenizer to be something that takes a line of text, takes it in, and then gives back a word at a time, all nicely sanitized. Okay. And the way I'm going to do that actually is I'm actually going to cache the results. So I only have to do this once. I'm thinking ahead a little bit. I'm thinking to our command system where I might have each command sort of examine the list of words and say, well, does this match pattern 1? Does this match pattern 2? So rather than having to regenerate that list of words every time I want to check a command, I'm just going to keep it here, and then we'll let the commands get it from the tokenizer, but the tokenizer will give it to you from a cache. So this will be a vector of strings. We'll call that the cache. And we're also going to want to keep track of where we are in the cache. So say the second time through, the second time I'm asking for the list of words, the cache will be fully populated. And so I'll just keep going until this iterator reaches the end of the cache. And I want to include here string and vector. All right. And then I also need a way to get the words from the line. So I'm just going to hold on to iterators to positions in the string, because I'm only going to read the line once. I don't need to actually hold on to the beginning. I'll just put the beginning in a current position holder and keep it advancing the current position until we reach the end. So what's that going to look like here? We're going to say that's line.begin to line.end. Okay, and then one more thing I need to do here, I also need to initialize the iterator to start at the end of the cache. All right, and one more thing, I know I'm going to need this now. We're going to have a read next string utility method, and this is going to be the thing that actually takes words off the line and puts it in the cache. So getString will read from the cache as long as there's room, as long as there's words in the cache. Otherwise, it'll call read next string to put a word in the cache and return it. So, what does that look like? Go to tokenizer.cpp, include our HPP, have using namespace mud dictionary here, and let's see. This is going to be reference. Get string. Okay. So, what did we say? We said basically if there's words in the cache, if we're not at the end of the cache yet, then go ahead and return a word from the cache. And then I want to advance the iterator, and I'm going to do post increment here, so that you know, the iterator starts at the beginning of the cache with mcache.begin, which is a word, and it keeps going until it gets to mcache.end, which is not a word. So I need to check that before I increment. Okay. Otherwise, I need to put a word in the cache, but I actually need to do a check here first to see, are there even any more characters to build words out of? Have I reached the end of the line? If I have, I'm just going to return, you know, a dummy word, a little signal here to mean there actually isn't a word. So the empty string. Except I can't do that. I want to do this, but I'm returning a reference, and I really shouldn't be returning a reference to a local or even to a temporary, which is what this is. Because what this is going to do is this is going to put a string on the stack. It's going to return a reference to that string, and then it's going to pop it right off the stack. So it might point to valid memory if that part of the stack hasn't been overwritten yet, but there's no guarantee, and it really is not supposed to work. So what I really need is I need a long-lived constant. So I'm just going to create a little constant here at file scope in an anonymous namespace. We'll call this no string, an empty standard string. So if I've reached the end of the line, then I'll go ahead and return no string. And then our last option is that there is still words in the line, and I want to put them in the cache. So let's do return read next string. Okay. So now we need to write that. Tokenizer read next string. All right. So what this is going to look like is I'm going to iterate over the line. So I'm going to keep going until worst case I reach the end of the line. Then I'm definitely at the end of the string. But also I'm going to break early if I reach whitespace, so that'll be the end of the word. And I'm going to build up a result, and I'm going to return it. What's that result? Rather than operate on a local here, on a temporary, and then have to copy that into our cache, I'm just going to go ahead and operate directly on a cache. I'm going to add a word to the cache. I'm going to say in place back an empty string. You know, pass no arguments to the standard string constructor. So that'll give me an empty string. And then go ahead and give me a reference to that, and we'll call it result. This is only valid in C++17 and later. So this version of InPlaceBack returns a reference. In earlier versions, in C++11 and in 14, InPlaceBack is void. It does not return a reference to the new element. So in 11 or 14, you want to do this as a two-step process. You'll do the mcache.InPlaceBack, and then you'll say result equals mcache.back. Very easy, and in 17, it's one line. Okay, and then the other thing I want to do is I want to advance the iterator. Because I've just read a word, right? So I've advanced the iterator here and get string. If I read the word a different way, I also want to advance the iterator. But I can't just say plus plus because there is a chance that my iterator got invalidated by this resize. InPlaceBack put another string in the list. So that it might mean that it's allocated it new memory and moved the whole vector to new memory. So I should just, to be safe, to be correct, go ahead and put the iterator where I want it to be, which is at the end. All right. So now, how am I going to build up the result? Well, first of all, I need to know, my break condition, my end of a word, and that'll be whitespace or non-printable characters. So anything less than ASCII space or above the range of printable characters, which will be the ASCII del character or 0x7f. And in fact, let's not have magic numbers. Let's give it a name. ASCII del is the name of the character at 0x7f. So we'll put that there, and then we'll say ASCII del or higher. This is the end of a word. This is whitespace or non-printable. Go ahead and break. Otherwise, for convenience, I'm going to downcase uppercase. I'm going to do that so I'll have an easier time parsing grammar and nouns and commands going forward. So let's see if it's between capital A and capital Z. Let's put that in the word, but let's downcase it. So subtract capital A and add lowercase a. Okay. And everything else will be printable characters. So we'll just put them in as is. All right, so this is good, but there's one case I need to account for, which is what if I have consecutive whitespace or non-printable characters? Because what that would end up doing in this case, or if I start the line with whitespace, what this would do is it would go ahead and add an empty word. It would break and it would return that empty word. And that's not what I want. I want to skip over any empty words and only return empty words as a signal to mean the line is over. So I need a way to skip through potentially multiple consecutive whitespace. So I'm just going to make a utility function here, advance to next token. If I've reached the end of the word, skip through all of the whitespace to get to the beginning of the next word. And then same thing at the beginning of the line, before I even try to read a word. Skip over all the stuff at the beginning of the line that isn't a word. All right, and let's also declare that utility function while we're here. Spell it right. Advance to next string. All right, and what does that look like? Shouldn't be that hard. Advance to next token. It's just going to be, again, that iterating over the line. When are we going to want to stop? When are we going to not want to iterate anymore? If we've reached a printable character. So if mpos is greater than ASCII space and it's less than ASCII del, so it's in that printable range, then go ahead and break. Otherwise, we'll keep going until the end of the word. And that'll be good because it'll put us right at end, and then we can return no string the next time without putting it in our cache. All right, that looks good. So let's integrate that into the interface. We're going to have our tokenizer. And we're going to do getString. Let's also put the end of line in correctly this time. We'll do it here too. So we're going to return their username, and for repeating the command back to them, we'll just return the first word. And this will give us a good interactive test also to see if we did it right. There we go. And we'll include dictionary tokenizer. And then last thing I need to do is I just need to update the C make list. All right, compile it. Something's not right. Advance to next token was, oh, because I called it advance to next string here. Okay. Well, I want it to be advance to next token. All right, it built. Let's test it out. Let's give it a drive. All right, so let's see if it downcases my username. Yeah, it does. Okay. And let's try, so if I say hi, it downcases, gives that back. If I do two words, I want to make sure it just gets the first word. So if I say hi, Ken, yeah, it just gives me hi. And let's make sure it trims out that leading white space. Yeah. I guess that's not really a good test because it's not reading after hi anyway, but all right. So to the best of our knowledge, it looks like we did it correctly. So we made a class that will feed it a line, and it'll give us all the stripped white space, stripped non-printable characters, broken up as individual words. And then if we really want, we can add a reset function in here to put the iterator back to the beginning of the line. And then we can use our cache and read it over and over and over again. And we'll end up doing that, but in a future part. So in our future parts, we'll start building up our command system using this tokenizer. And I'm looking forward to that. So this was Let's Code a Mud in C++ 11, and my name is Ken. Thanks for watching.